Good morning and good afternoon. On behalf of Redis Labs and Forrester Research, thank you for joining us on today's webinar entitled Analytics at the Speed of Business with Redis and Spark. Today you will hear from Noel Yuhanna, a principal analyst with Forrester, who will provide an overview of why data and analytics needs to be real-time, drivers and challenges for real-time analytics, the roadmap for fast data, along with practical recommendations. Following Noel, Leena Joshi, Vice President of Product Marketing at Redis Labs, will provide a brief introduction to Redis, analytics with Redis, Redis and Spark integration, making analytics cost-effective, along with extended analytics with Redis Modules. During the broadcast, if you have questions, please use the Questions tab to post your questions, and they will be answered in the order they were received following Noel's and Leena's presentation. This webinar is being recorded and will be available for download to share with others across your organization. Again, thank you for joining us today, and at this time, I'll turn the broadcast over to Noel. Noel, welcome.
Yeah, thanks. So this is Noel Yuhanna, Principal Analyst with Forrester Research, and thanks for having me on this webinar. Today I'm going to be talking about running analytics at the speed of your business. As a Forrester analyst, I get to speak to many customers. In fact, I speak to about 2 to 3 customers every day. And these customers are sometimes mid-sized companies, sometimes very large organizations. And they want to talk about these different types of scenarios about what are things they got to do from an analytical perspective, you know. Now, if you look back in the early days, so over the last 20 years, right, analytics has changed quite a lot. In fact, I remember 20 years ago where we used to run analytical kind of reports, right? It used to take us weeks to generate those reports for the businesses, actually. And we used to polish those reports and then give it out to the business user. And by the time it got to the business user, it was pretty much stale, actually. Yet, you know, those were the state of the art or technology we had back then, 20 years ago, right? But more recently, things have changed a lot, especially from a real-time perspective, right? Everything is moving towards real-time. From a business perspective, from a reporting perspective, from a query perspective, from an interaction perspective, from a customer intelligence perspective, you name it, right? We're moving towards that whole real-timeness. We're not there yet. I think none of the businesses are there completely 100% real-time, but it's a journey, right? We got to go on this journey. And this is what I'm going to talk about a bit today, about this whole, what's the big challenge which organizations are running from an analytical perspective, and why should they care about having an improvement on being able to deliver real time, right? So, you know, a big theme for this is data bottlenecks today are creating business bottlenecks that's impacting growth and innovation. So we hear that all the time from customers, whether it's financial services, healthcare, retailers, oil and gas, you name it, right? I mean, there are bottlenecks today in data, right? I mean, data is in silos, data is in slow, clumsy machines out there, yet we can't deliver those impactful reports and queries which need to drive businesses, right? So definitely it's creating a bigger impact, and especially as the volume grows, this creates a even bigger impact, right, for organizations. So from a digital transformation, if you look at it, today the currency, you know, data is a new currency. It's the oil. It's you know, bacon and other things, right? I mean, people talk about data as a new thing. In fact, more than 8% of enterprises are monetizing on data. Monetizing on data. We couldn't do that 10 years ago, right? So things have changed a lot today. But the biggest problem is, you know, what if your data is slow and that's not being utilized for analytics or in a timely manner, right? And this is a big issue which we feel and we face in organizations today, right? I mean, how is the data going to be delivered in a more effective sense, right? How do you have a platform that can drive a better success, better innovation, better growth, right? And how can we collaborate and share the data across the enterprise today in an effective sense? That's not being done today. There's a lot of these line of businesses, they have their own data, you have different types of IT organizations. It's definitely a bigger challenge. And as the volume grows and as we become in a more digital organization, you really have to be able to share this data in a more effective sense. Next slide. So if you look at it, this is a very interesting slide and a survey data. Only 12% of enterprise data is used for analytics today. That's just 12% only. Wow. Right? What happened to the remainder? I guess where did it go, right? Just because we just push that data into silos or different types of archival repositories, you can't really utilize this data in an effective sense. So it is a bigger challenge in the industry today, right? And I think we have built these data warehouses which are awfully slow. The data moves from a transactional system to the operational system to the analytical systems. By the time it reaches the analytical system, it's many, many days later, right? So definitely creates a bigger challenge. Today, business users are thinking of analytics as a set of boring reports and dashboards, right? If you look at this guy looking at his watch, he's ready to leave the office, actually, at 5 p.m. because no one wants yesterday's data tomorrow, right? This is a big challenge out there. So I think the more important thing is how can you deliver more value and how can we drive real-time data sets, right? Next slide. So, if you think about databases, right, I mean, shifting gears from analytics to databases. Databases are the fundamental platform for a lot of analytics and real-time interactions and queries. And what's the big challenge today in a database sense? 80% of people complain about performance. It's not surprising, right? A lot of DBA system admins and all of the architects spend lots of time and effort in tuning and optimizing these databases. The volumes are growing, yet our systems are slower and slower. I guess how do you deliver more performance, right? Integration is an issue. People, resources is an issue. Securing private data is an issue, right? All of these create a bigger challenge, right? So I think definitely, I think every organization have to realize how can we really improve our data platform. Next slide. So what are the trends we see out there affecting database strategies, right? I mean, you name it. And I don't want to go through the list up there from the strategy perspective, but definitely it's the volume, right? Explosion, the transactional increasing of there. There's a new analytics requirements right now. People are requiring more self-service, more intelligent, more integrated data sets for analytics, right? If you look at business users, they don't want those old reports. I want to be able to access my own reports in my own style. That's what the business users what they want. It's not something they want canned reports, right, so to speak, right? They want faster access. They want better security, right, better formats. Be able to support all types of data formats, not just traditional data sets as well, right? But like structured data sets. But what about unstructured data? What about semi-structured data sets as well, right? And this is a huge requirement from a database perspective going forward. Next slide. So if you look at it in terms of what businesses want, they want real-time access to information, right? And I think if you look at it, I think one of the disruption has happened over the last many years is the mobile devices, right? We can't afford to have data which is old, right? Imagine your emails coming in tomorrow. Yeah, right? I mean, how would you react to that situation, right? Right? I mean, that's exactly is with the business data. We've done it for the consumer side of the house, but the business side is also starting to gain a lot of ground. Mobile enterprise is playing a big role in the enterprise today, and this is all about faster data. Competitive pressure, which is huge as well, right? To be able to act quickly enough, right, on the data. Not slow-moving kind of a iteration from an interaction perspective, but it's more competitive pressure there. Pressure from from businesses, they want this data in real time. The marketing, the sales, the financial groups out there, They want data like now. They can't afford. They're going to build their own database otherwise, or their own data platform. And I think that's where they're looking at options out there, right? New analytics, new insights, global businesses, IoT, you name it, I guess, right? I think everyone wants this whole real-time access and real-time business. Next slide. I think, if you look at the trends, there's this emergence of what we call fast data. And I'll talk a bit more about what exactly fast data means. So traditionally, if you look at the yellow bar, it's about traditional sources. It's mostly batch, right? This is where we came from, mostly batch-oriented. And then we got some real-time streaming data coming in from IoT, sensor data, right? Geolocation. But there's a middle ground between the two, what we call fast data. There are certain data sets that need to be quickly delivered to the business user or the analytical platforms because you want to make better decisions and decisions quicker and faster and more accurate as well. So this fast data, we believe, is an important element in a business success today. If you are not on your fast data strategy, you probably are going to be left behind from a competitive perspective, but also from a growth perspective as well. So we see a lot of these organizations, financial services, retailers, banks, insurance companies, some of the cutting-edge companies out there are deploying a fast data strategy. They're not going to tell you about this, but they are working already on this for the last few years, And this is very important for, I think, every organization to latch on. Next slide. So what exactly is fast data, right? It's a combining the system of engagement with the system of record, right? And I think the more important is getting these things together more quickly enough to support new next generation of business analytics, right? So system engagement is more about mobile, web, smart devices, frequent changing data sets, and more real-time in nature. And system of records, more legacy in nature. It's more high transactional environments. We estimate 20% of your data today in the enterprise is fast data. 20%. And that'll double in the next 3 years. It'll double. So definitely, I think there's an issue there, right? So I think 20% of the enterprises are definitely doing in terms of fast data. Now, the important thing here is that the fast data story will be important. We are moving towards 100% fast data in the coming years. And what it means that be able to access any information by any user anytime when they want it, right? It's not that they're going to wait for 24 hours later, right? I want to get this data like now. Can I do analytics at the speed of transactions, right? That's the important goal there. Can I do analytics at the speed of transactions? We have never done this before. Remember that. Because our systems haven't been deployed or architected in that manner. That is, I think, the differences out there with this fast data strategy. Next slide. So the key capabilities you need for fast data strategy is that you need to obviously have something of a compute layer, a more in-memory compute layer, so to speak. And why in memory? Well, because low latency access, right? Faster access. Your iPhone today or your Android devices are going to have terabytes of data or terabytes of memory in the coming years. Think about how many songs can you put in the terabyte, I guess. But if you're moving to terabytes, what about your databases? Are they going to be just terabytes? No. You're going to have petabytes into memory. Think about if you have petabytes in memory, what can you do with data management? Right? That is the fundamental thing here we're talking about. Low latency access to large volumes of data, ability to integrate disparate sources from many different things coming together, continuous availability of databases and data, scaled architecture, and hybrid environments like on-premise and the cloud will be important, highly automated built-in intelligence. So these are things what we see in a fast data strategy. Now, so if you're building up a strategy today, if you want to call this fast data strategy, what are things are you going to be looking for? Well, in memory, right? Being able to integrate data, being able to be continuously available 24/7 across the globe, scale out, not scale up, but scale out. I can put multiple nodes in a cluster to scale out. It's also running on-premise and cloud seamlessly. Things could be running on-premise, some things could be running on cloud without your interaction. That's where we are heading towards, right? Cloud is a big platform for this. Highly automated and intelligent platform is, again, very, very critical as well. Next slide. So, interestingly, talking about Spark, right? I think everyone has heard about Spark, but let me kind of talk about it as well. It's basically this platform. It's an open source platform that uses in-memory to scale, process, and provide a low latency access, right? We've had MapReduce for many years, but we weren't happy with MapReduce because it's a very, very batch-oriented platform, right? It helps a lot for those batch programs, a lot. But we're moving towards real-time, right? So I guess one of the key benefits we've seen is obviously 10 times to 1,000 times faster results with Spark, with in-memory technologies, in other words, right? If you compare in-memory with things like disk drives, right? It's about 10 times to 1,000 times faster. This is what we hear from customers all the time. It supports SQL interfaces. It supports machine learning. It supports graph data processing. It supports streaming data as well, right? A lot of these technologies are there, which I think really makes it more valuable interaction as well. Easier to basically deploy these applications, whether you're doing it in Java or Scala or Python as well. I mean, there are a lot of built-in functions available with Apache Spark right off the box, which I think is very, very useful. If you look at the use cases out there, you got sensor data processing, you got stream processing out there, you got interactive processing, you got all kinds of machine learning, IoT, complex. I mean, there's fundamentally things, you can do many, many new things which you could never, ever dream of doing in a traditional platform, actually. I mean, these are the things which you can do with Spark today, which I think is fundamentally the game changer. If you're not really adopting Spark, you probably are going to be left behind. I'm telling you that, because we are seeing lots and lots of companies out there who are adopting Spark in a big way. In fact, today adoption is already just, in fact, this Spark came just a few years ago, 30%. Whoa. And this will double in the next 3 years to 60%. Are you going to be one of those 60%, I guess, right? But the more important thing is you can do all kinds of things with graph. With Apache Spark, from a text to graph processing to batch, or even real time. I think the more important thing is the balancing between real time and batch, which is what Spark delivers in terms of its value from a customer perspective, right? Next slide. So if you look at it in terms of where you are on this fast data strategy today, right? You definitely are moving to this fundamental thing about, okay, can I really drive my, like today people are delivering next best action, right? Or business process assistance, or making sure we can have minimizing the operational bottlenecks that they have, or doing customer engagement, right? This is where we are. If you look at it from where we are coming from, we're coming from a traditional reporting, predictive analytics, taking too much time to do the insights, and we had bottleneck from a data platform, from a delivery perspective. But where are we heading towards, right? From a fast data strategy beyond 2018 and more, is obviously cognitive engagements, cognitive computing, right? It's all about intelligence, being able to solve quickly enough for these environments. Instead of you going to the data should come to you, right? We're not going to track 1 million records. Imagine if you're going to scan 1 million records. Well, that's not good enough. It'll probably take you 1 million days to do it. We don't have time, right? So the thing is, you got to look at those things. Can we make the data more intelligent, right? And I think this requires a strategy, first of all. You need to really have a platform to drive that as well, right? Address customers' need and customize experiences. We are already there with customizable experiences, with customer intelligence, customer experience, where if you have 1 million customers, you want to treat each and every customer of yours as a king, right? Because you want to make sure you deliver the lots of value to that customer. If a customer is happy or not happy, What are the things you're missing in your product offering, right? I mean, those things are very, very important. And I think this is exactly why this big data strategy or the fast data strategy becomes very, very important for organizations. Be able to understand the customer experience, understand, like if you're walking in the mall, all of a sudden there should be an alert. Hey, Noel, you were interested in a pair of jeans. We'll give you 20% off. Out of the million customers they had to reach out to me only. Why? That is customer experience, not those million other people, I guess, right? So can you individualize that customer experience? We are already on that track right now, but I think beyond 2018, we're going to see a lot more adoption of that as well. Next slide. So, I mean, what are the recommendations, I have for you guys? First of all, obviously, big data, this whole fast data strategy is very, very important. You should definitely be embracing that. And fast data strategy is all about this in-memory compute layer, which is going to be very, very important for organizations going forward. In the era of big data, you need to look beyond traditional data architectures to succeed and gain competitive advantage. In other words, you got to look at architectures. Your architectures may be very old, right? When was the last time you changed your data architecture, your whole data platform architecture as well, right? Think about those things. You can't just put more memory and drive a data strategy today. No, you got to look at all the other solutions. You got to look at the hardware architectures. Maybe I need a more scaled architecture. I need to buy a smaller 20-core machines, 24-core machines, as opposed to buying 100-core machines, right? And maybe I can scale out as well. You got to think about those strategies. Maybe I'm going to put certain data in Europe, certain data in Seattle, certain data in Australia, right? And you got to look at those strategies as well. You got to think about software as well. What sort of software do you need in this platform that can drive the strategy for fast data as well? Especially with real-time analytics you're doing, especially you're doing these faster analytics which will drive business success. What are you going to do? Think about those things. Also look at fast data strategy needs to be on your roadmap, right? Focusing on making data available more quickly to the business users and decision makers, right? I mean, I think the strategy needs to be there because definitely if you don't have that platform, this definitely makes it a bigger challenge by itself. Look for automation, simplification, ease of use, and database solutions that help you faster time to value for initiatives as well. Automation simplification like machine learning becomes very important in realizing the value of the platform as well. Because sometimes you have a lot of data coming in, you are difficult to react to the data. Why? Imagine looking at 10 million records. Humanly, you'll not be able to look at those 10 million records. It may take you a couple of years to do that, right? But machine learning can pick it up, right? Go through the 10 million in a few seconds and tell you what the data tells you, right? And like, hey, there's an issue there with maybe customer churn. This person clicked on a couple of times onto how do I remove my subscription from your services, right? I mean, that could be a trend happening somewhere behind the scenes. You would not even know about that, right? So things about those would be important. Look at in-memory scale-out architectures, as I mentioned, which is going to be very, very important for growing business analytics as well as innovation. And also open source. I didn't talk a lot about open source, but I guess this is a very important area of focus. We have seen open source gaining a lot of ground. I think every organization, whether even the Fortune 100 companies, are investing quite a lot on the open source platforms, from a software perspective. I think this is becoming a very important trend where you will be able to you're able to contribute to the open source platform, but also, this platform becomes not really a vendor lock-in, right? Because if the vendor moves on, that's fine. You still have an open source platform available for the next 10 years, for the next 100 years, who knows, right? If you own the platform yourself as well. So it's a very important strategy to be looking at when you're looking at your fast data strategy, to look at how you can actually leverage some of the open source facility as well. So running analytics at the speed of your business, I think it requires this fundamental thing on fast data strategy, which I think is going to be important as well. Next slide. With that, I'd like to thank you and hand it over to Leena Joshi.
Thanks, Noel. My name is Leena Joshi. I'm VP Product Marketing at Redis Labs. And before I jump into my presentation, if you don't already know who we are, Redis is an open source in-memory data structure store. We support high-performance operational analytics use cases, and Redis Labs is both the home of the open source as well as a commercial provider of enterprise-grade Redis. For those of you who don't know anything about Redis, Redis is known for three main things. One of it, if you Google Redis or read anything about Redis, the thing that stands out is our performance. Redis can deliver millions of operations per second at sub-millisecond latency, and we at Redis Labs have benchmarked our enterprise-grade Redis to deliver 1.5 million operations per second at sub-millisecond latencies with just a single standard AWS EC2 server. So that's sort of one of the big things about Redis. The second thing is it comes with a set of data structures which simplify application complexity, which make it really easy to implement complex functionality and can be used as Lego building blocks to solve particular application problems. And for the specific application problems that these data structures are useful for, there is pretty much nothing else, no other technology that you can find that will solve it more efficiently, with greater performance, and with as few resources. So it solves a range of different problems with a great deal of simplicity and versatility. And lastly, at RedisConf this year, just a few days ago, we announced the extensibility of Redis. So now you get this simplicity, high performance, high availability of Redis. Basically, you can extend this through the notion of Redis modules to be applicable to pretty much any scenario that requires a database. Jumping into a little bit of data structures, as I mentioned before, developers use data structures like Lego building blocks, and the big deal about the data structures is that they come with a set of operations that allow the data to be processed at the database level rather than the application level. So you eliminate back and forth between the application and the database, you solve complex problems with a great deal of simplicity, you get cleaner, more elegant code, and faster execution times. In terms of extensibility, the modules that we recently announced extend Redis to an infinite number of use cases. Modules are add-ons that use a Redis API to seamlessly add to its use cases and data structures. Because they have access to all of the Redis internals, they enjoy Redis' simplicity and high performance and scalability and availability. Modules can be created by anyone, and some of the examples of the modules are below. Full text search modules, enhanced JSON modules, linear algebra modules, and so on. And lastly, I talked a little bit about performance. There's a benchmark that we did last year comparing Redis Labs versus some of the other NoSQLs that you can find in an end-to-end application scenario, a high volume of writes. You can see that we have the highest throughput at the lowest latency. And the second distinguishing factor there is, in order to get to this very high throughput and low latency, we actually need very little hardware. So three things to take away from the performance slide. You get millions of operations per second, second at sub-millisecond latencies, and third is with very little hardware. With 1 or 2 servers you can get there versus the hundreds of servers you would need with other technologies. Redis is pretty widely adopted. Our cloud offering, Redis Cloud, which runs on 4 different clouds and is integrated with a number of platform as a service providers, has 50,000 users and over 6,100 enterprise customers. Redis Labs Enterprise Cluster is downloadable software that we use internally to run Redis Cloud. This has been available as downloadable software for enterprise-grade Redis deployments since last year, and that has over 100+ enterprise customers already. So we're seeing a tremendous amount of traction behind this enterprise-grade Redis. Now, shifting back to why use Redis and Analytics. Redis, because of the data structures and the versatility of the commands and operations that come with it, is already deployed in many use cases like real-time computations, business applications, time-based analysis, and so on. I'll quickly run through a couple of examples, maybe just dip my toe in, what makes Redis so special for analytics. So one example scenario that I cover is using Redis for something like bid management, which is a popular use case. Now, the application problem is there are many users bidding on items, and not only do you need to keep track of bids, you also need to instantly show who's leading, in what order, and by how much. You also may need to display analytics like how many users are bidding in what range. And if you try to do this with disk-based databases, you find that it's too slow for real-time, high-scale calculations. Now, Redis rocks this in two ways. First of all, it's in memory, so it comes with a great deal of high performance, low latency already. And then the data structures lend a second level of performance boost to Redis. So Redis comes with a data structure called sorted sets. Sorted sets automatically keep lists of users and scores updated and in order. And Redis also comes with a set of commands that will solve your analytics problems. They will get your top users, zrank will get any user's rank instantaneously, count will return a count of users, and zrange by score will return all the users in a range by their bids. Now, so what is the big deal about this? These operations are executed in memory right next to where the data is stored, so they're extremely fast, they eliminate application complexity, and therefore can be deployed at very, very high scale. And this is just a graphic that shows how you could potentially use Redis sorted sets, just a conceptual idea that we keep the data already pre-sorted and accessible with the Redis operations. Another example for analytics is using Redis for recommendation engines. The application problem is you want to keep track of users, items, likes, dislikes, and similarities. You basically want to do set comparisons of user likes, user dislikes to create similarity scores, which can then be stored in the sorted set. Set comparisons of similar user likes and dislikes also need to be combined with items that are not yet purchased by the current user, so this will get you suggestions. And you want to do this with very high speed, very low latency, and the reason Redis is awesome for this kind of scenario is because Redis sets, another data structure, is basically unordered collections of strings. Set operations, such as creating intersections of multiple sets, adding multiple sets, determining membership, retrieving all values in a set. These are all, again, built-in operations that come with Redis. And sets and sorted sets combined can give you very, very great, simple, extremely high-performance mechanism to get to a recommendation engine. So once again, this is just a graphic view of how you would potentially use Redis sets. I will not dive into this example, but you will get the slides after this call and can take a look at how it might be used. Another way to use Redis in analytics is combine it with Spark. Noel talked a little bit about Spark and the amount of traction that it's gaining in enterprises. We have created a connector for Spark and Redis. And with Spark, with this connector, you're able to use Redis both as a data source, a data sink, as well as an internal accelerator for your Spark queries, for your Spark processes, as well as for Spark queries. Now, this connector is on GitHub. It is open source. It allows Apache Spark to directly access Redis data structures. And why would you want to do that? So as I mentioned before, Redis data structures accelerate analysis and processing. Redis sorted sets as an example, and we'll take this as an example for this webinar. They accelerate something like time series analysis by up to 100 times compared to sort of other dumb NoSQL stores, I will say. To prove this, we took example time series data, stock prices for 1,024 stocks over 32 years, and we ran analysis comparing what happens if you use Spark with HDFS, Spark with Tachyon, which is an offline off-heap cache, Spark just using in-process memory, and Spark using Redis. And you can see the tremendous acceleration that Redis sorted sets provides to time series analysis. This is a time slice query. The Redis is faster by up to 100 times compared to HDFS, and over 45 times compared to Spark using Tachyon or just in-process memory. If you need more details about Redis and the Spark integration, the links are in the slides. The slides will be emailed to you. There's a GitHub link for the Spark Redis connector package. There is also a link that tells you how to get started with Spark and Redis. This is on our website under Solutions, Spark and Redis, and there is also a blog post that will walk you through how to connect and get started with Spark and Redis. Now you're wondering, all this talk about in-memory and analytics running in memory. Memory is expensive, and so how exactly are you going to be able to run terabytes and petabytes of memory? Now, there are alternatives to DRAM that have been emerging over the last few years. Now, these alternatives perform are slower than DRAM, but also much cheaper. So what we did at Redis Labs is we enhanced Redis so that it can run on a combination of DRAM and alternative memory technologies such as flash or 3D crosspoint or storage class memory. And the enhancements that we made are not a simple port of Redis to flash, but really there are two dimensions to this. One is we modified or we enhanced the open source so that it can access the slower memory, I will call it, be it flash or 3D crosspoint or storage class memory, in a multi-threaded and async fashion so that it's an optimal access. And the second optimization we did was we made it configurable so that you can configure how much data you store in RAM and how much data you store in flash. The second level of optimization makes sure that you have keys and hot values that can be stored in RAM, and then the cold values can be stored in flash. This optimization can be done dynamically on a per workload basis, so you can choose what economic model works best for your analytic workloads. This is how you basically get to terabytes of data in memory, is you can judiciously choose what is the trade-off you want to make between performance and cost. And while this sounds very simple, like you move a slider and you're able to change your RAM to flash ratio, behind the scenes we have actually implemented complex functionality that adjusts the RAM to flash ratio over a cluster of Redis instances running in a pool of servers. Is it possible to get really high performance in this scenario? Well, we benchmarked on a single Dell server with the latest class of memory technologies. It's called NVMe based flash, but it's essentially flash. And we got up to 2 million operations per second with sub-millisecond latency, where 80% of the data was in flash and 20% of the data was in RAM. So this is actually really impressive results. As you can see, there's very little compromises that you might have to make on performance if you're using a combination of RAM and flash. What types of customers would use something like this? Well, we already have a customer using Redis for genome data analysis. The raw data set was 31 terabytes, and even after optimizing it through encoding the data and using Redis hashes to store the data, which is another data structure in Redis, we got it down to about 5 terabytes, which would still be a pretty expensive workload to run in memory. However, by using Redis on Flash, this customer was able to accomplish their genome pattern detection analysis and also save about 97% when as compared to a running the analytics workload completely in memory. So you can use Redis data structures to solve a number of analytics scenarios. You can also extend the analytics scenarios that you utilize Redis in with Redis modules. So earlier this month, we announced the availability of Redis modules. These Redis modules can add a variety of different functionality to Redis. If you go to www.redismodules.com, you will see already a number of these modules. For example, the full text search module and the image processing module already on there. What is the big deal about these modules? Now remember, you're getting any database functionality inside of Redis. With just a few weeks of development of the full text search module, this is the result that we saw. Basically, by running Redis Search, which is a module that we created for Redis, we've created the world's fastest text search engine. Compared to other search engines that specialize in search, Redis Search delivers 32 times higher throughput in a full text search scenario and 85% higher throughput in a type ahead or prefix search type of scenario, with much lower latencies as well. So basically, if you have other database functionality that you need to implement, such as graph functionality or enhanced JSON support, Redis modules will pretty much be able to extend your analytics in whichever direction you want to be able to take it. You can take a look at www.redismodules.com, take a look at all the modules that are on there. And if you feel up to it, maybe you can submit your own module as well. So the big deal about modules, if I haven't said this before, is you can basically pick and choose any arbitrary functionality or data structures that you can add to Redis. This gives you much faster time to market than picking out specialized databases that solve specific problems in your application. So this makes Redis almost infinitely versatile and applicable to any database scenario. So in terms of next steps, I know I ran through a lot of analytics scenarios very quickly. You will get the slides emailed to you. You can access Redis with Spark on our website at redislabs.com under Solutions. You can also learn more about Redis on Flash, same space, and you can learn more about Redis modules at www.redismodules.com. With that, I will conclude my section of the webinar, and we will go into questions. If you have any questions for myself or Noel, please type them in the chat window at the bottom. I can see a few have already come through. Noel, there's one question for you. What types of traditional businesses do you see needing real-time analytics?
Yeah, so that's actually a very interesting question. What we see is that I think every business, I guess, is moving towards real time. Whether it's a retailer or insurance company, manufacturing, oil and gas, you name it, right? We hear a lot of these customers from all of these various verticals asking about real time. So I think traditional businesses or new business, I think everyone wants to be on that real time bandwagon because it's a critical thing. You can't be running old, stale analytics anymore in your business, right? But reaching to that everything real time, it'll take a while, right? I mean, I don't think we can move everything to becoming real time because lots of data exists today. If you look at it, fraud detection, right? Fraud detection is a big thing in financial services, retailers, healthcare, patient management, patient monitoring, right? I mean, you're doing any type of stock analysis, network analysis. I mean, all of these require real-time analysis, right? So definitely we are moving towards that model all of these traditional businesses who have existed for many, many years are changing the way in IT organizations about how we can deliver more value to the business in a real-time context, right? But as I mentioned, no one has got a silver bullet and say, okay, we're going to throw all of our existing systems and platforms and move to real time and we get there like next week, It won't happen, right? I mean, it'll take a while, but and that's the reason why the big data strategy, this fast data strategy I mentioned, your 20% of data today is fast data, and the 20% are the ones you are looking for, that sources of data that needs to be tied and integrated for customer intelligence, customer analytics, or any type of business requirements. I think those are the ones which are going to be critical for organizations to succeed going forward. So I would recommend you guys to look at in your organization what kind of data is fast data. What are the things I need to deliver like right away? I can't wait for like hours and days for that, right? I think those are the good spots to look for data. And I think you've got to interact with business users, you've got to interact with enterprise architects and kind of build this whole platform and start to look at it. Whether you're in from a retailer, insurance companies, or even banks or oil and gas, I mean, I think everyone has got to be important as well. So.
Cool, thanks, Noel. There are a couple more questions that have come through. The first one is, what does it take to prep non-structured data to be Redis ready? Can you describe that a bit, please? Just to answer that question real quickly, the Redis is schema free, so you can decide to choose however you want to store your data in Redis. It basically can accept any kind of structure. The purpose of using the data structures in Redis are that some of them can really accelerate processing. Depending on the type of analytic problem you're trying to solve or the transactional problem you're trying to solve, you might want to pick a data structure that fits. An example I'll give is, let's say you have user session data from your websites. You might want to pick the hash structure. This is typically the recommendation that most people, or this is typically the way people use Redis for user session data. This is because the hash structure is almost infinitely extensible, and you can accelerate individual fields even within your data to manipulate them directly and at very high performance. Another question that has come through, Noel, is actually for you. First, do you see real-time analytics being in addition to or instead of traditional warehouses?
Well, yeah, that's a good question. I mean, for now, it's in addition to, warehouses. Actually, traditional data warehouses still have value, especially for batch processing. There's a lot of transformation that happens in data warehouses and all, but they're slower, right? As I mentioned, moving a data from transactional to the operational to the analytical, it may take 48 hours to get you the data, right? That's old stuff, right? And those are still important. Yet this in addition to real-time analytics, you need a platform to be able to drive a strategy. As I mentioned, the 20% data that needs to be real-time. That's actually where the real value comes in for organizations. So today, I would say it's in addition to, but where we are moving towards is real-time everything, right? That's a journey we are on it. Now, the traditional data warehouses are not going to hold good when you talk about this long-term strategy. Short-term, maybe it's okay. You can complement them. Long-term strategy, you got to rethink your strategy about data warehouses, because you're moving towards this more real-timeness for everything. As I mentioned, memory plays a very, very big role here, especially distributed computing, which makes it even more important from a scale-out architecture, from memory computing frameworks. So you want to be able to do modeling. You want to be able to do aggregation and real-time insights within this whole real-time platform. Which you would not be able to do in warehouses, right? Your competitive advantage would be real-timeness, all right, of data. So definitely, I would say short-term, it's in addition to your warehouses, but in the longer term, looking at everything into memory platforms,
Cool. Thank you. Another question has come in. Can you compare Redis to MongoDB? Does it make sense to use both databases together? So the answer to that is Redis runs in memory. It's a data structure store. MongoDB is a disk-based database, and it's also a key value store at a very high level. If you were to compare the two, I would say the biggest difference between the two is the high performance of Redis. If you really push MongoDB very hard, you might get to 1,000 operations per second with one server. But with Redis, you can get to millions of operations per second at sub-millisecond latency with a single server. It does make sense sometimes to use Redis and MongoDB together. In fact, that is a very common scenario that we find where Redis is being used for the real-time processing of data, for the real-time both operational, transactional, and analytic processing of data, while MongoDB is being used for longer-term storage. So yes, we do see Redis and MongoDB often used side by side and together. Noel, here's another question that has come through for you. Do you anticipate cost savings from going real-time versus traditional data warehouse?
Yeah, again, I think that's a good question. Do you really save money or just going with real-time? Well, it's first of all, building a warehouse takes a lot of time and effort. We have seen customers spending not months, years trying to build a warehouse, actually. It takes a long time, actually. Lots of dollars spent in a warehouse. And at the end of the day, you may not even get a value out of that warehouse data because it's old and obsolete or even stale when you get to the data, right? Especially with this new modern requirements for the business, right? I mean, it was good 10 years ago, right? 5 years ago. But today, I think we are really running business at a high speed, so to speak. So I would say, with this whole data platform like real time, you can be up and running in a few weeks, in fact days actually, compared to a warehouse, which may take, as I mentioned, months and years to do with it. So there's definitely a cost saving right there when you look at it. You don't have to spend months and years trying to build a real time analytical platform. Why? Because you start small and grow. You don't architect this warehouse for everything to be included beforehand, but you start very small. You look at fewer sources of data that needs to be available to the business users right away. That's the data. And then not all data needs to be in the memory, available from a self-service perspective. Only a small portion of the data needs to be there. And then you grow and add more and more and more, right? That's how you grow. And that fundamentally saves you money. And I think you don't need to have, or you can actually eliminate hardware and software platforms from a traditional data warehousing architectures. In a real-time manner, you don't even need those multiple stacks. No, we have built so many stacks that by the time the data gets to the top layer stack from a delivery perspective, the data is slow down that such that you may not act upon the data. You can't take action on the data. Imagine you can collapse the stack to a single layer. Right? Think about it. What does it mean? You can eliminate hardware and software. That's saving 20%, 30%, 60% of the cost saving in a data platform. That exactly is what we're starting to see happening in the banks, the insurance company, retailers, right? And that exactly is the value you bring with these modern architectures,
Got it. Good. Awesome. Thank you, Noel. One more question has come through. Is it possible to store on disk a snapshot of the data in Redis and restore it? Example, store on disk a daily snapshot and at the end of the month restore to calculate analytics. Absolutely. That might not be the most optimal way to do it, but yes, it is definitely possible to do it that way. There are probably also a couple of optimizations we can help you with that. Another question that has come through is, does Redis follow a typical data modeling process like RDBMS? I would say Redis is way more flexible than RDBMSs, and yes, you can use your standard data modeling with Redis, but it's not necessary. can move a lot faster with it as well. I think those were all the questions that have come through. Thank you everyone for your time today. Thank you, Noel, for presenting with us. Thank you to the organizers, Redis Labs, and we will look forward to mailing you the slides, the recording, and hearing from you again. Thank you all.